Good morning. Thank you very much, Professor Rowiński, for this very nice introduction. I will preface this that many may wonder about my name. I am Polish, but I was born in France. I do speak Polish, but I will continue my presentation in English because this is the well, the standard here. So I have been asked to present the evaluation process for ERC in the physical sciences, but I would like to say immediately that this is no different from any any of the evaluation in any of the domains of ERC, and much of what I have to say will just be echoing what has already been said, in particular by Professor Jajszczyk. So, and I also would like to say from a personal point of view that I have been awardee of an ERC grant, an ERC Advanced grant, which allowed me to actually come back to Europe. I had spent 20 years full-time at the University of California in Berkeley and was offered a job in Paris, but with no funding, no funds to do any research. And fortunately, the ERC was there, and I applied, and I was fortunate to get a grant, and this really helped me establish a research, from scratch, a research program in France, quite late in my career, actually. So anyway, so as has already been mentioned, excellence is really the sole evaluation criterion. There is no other evaluation criterion which is different from many of the other European Union projects, which always have some other kind of criteria to kind of level the or provide some balance for different criteria. But excellence is really the essence of ERC, and as already has been presented, but I will kind of emphasize it. There are two aspects for evaluating a proposal. One is the research project, which really is the most important. Is the research project, does it present something new, some new ideas, some groundbreaking new ideas? What is its potential impact from the scientific point of view? How is it, what is the methodology, that is the scientific approach that is proposed? And of course, is it feasible or is it completely crazy, right? It has to be kind of argued on the basis of something that actually can be achieved. The other aspect, of course, is that the ERC is giving funds to the PI, to the principal investigator, and so the principal investigator, we have to trust them that they can carry out what they have proposed to do. So we have also to assess the principal investigator in terms of various criteria, intellectual capacity, the evidence for creativity, and also their commitment to carrying out this project that they propose. So, of course, the first thing is to define what is excellent. And so here are some questions that the reviewers and the panelists the remote reviewers and the panelists will be asked to answer when they write their report or discuss the proposal. So, for the first point, being the groundbreaking nature and potential impact of the research project, to what extent does the proposed research address important challenges? How can you, you have to argue that what you're proposing is an important scientific program. To what extent are the objectives ambitious and beyond the state of the art? That is, you're not just continuing something that you've been doing or somebody else has been doing and just incrementally adding something, but it has to be ambitious and novel. And to what extent is the proposed research high risk, high gain? that is really an important point here, is that we value proposals, we encourage proposals that may not succeed, that you don't know initially whether you cannot be guaranteed that what you're proposing will be successful, and that because it is ambitious and novel, but you can argue that if it is successful, then the impact, the payoffs will be significant. So, and there is, of course, a lot of information on this you can find on the ERC work program website, and I encourage you to look at this and read this. I mean, many times scientists don't like to read instructions, but it's important for this process to do so. So the principles of the peer review system, again, it is not specific to the PE domain, even though we have these 3 sessions, we have been broken up into the 3 domains. We try in ERC to keep, we are tracking that there is coherence across all the broad research domains and fields in terms of the evaluation. In the Scientific Council, we spent a lot of time discussing it and evaluating this. We, of course, have a forward-looking approach in particular, an open mind about what might be an ambitious and high-risk, high-gain proposal. Also, the funding allocations are independent of the panel structure. It's again a bottom-up approach, where it is the proposal pressure, how many proposals are submitted in a particular area, that will determine the how much funding is available. Well, flexibility and inclusiveness. And also interdisciplinarity is encouraged, which is why I insist on the fact that we are not, we have to have different disciplinary panels, different domains, but this is just because we have to work somehow. But also we like to be flexible and encourage interdisciplinarity proposals that may span across 2 or more panels and 2 or more domains. Again, for the evaluation criteria, first the scientific approach, then the PI. Yes, so I insist here on just a simple, again, feasibility. Is your methodology appropriate to achieve the goals of the project? To what extent are you developing some novel methodology? And are the resources and what you're proposing feasible in the time scale of the proposal? That is in principle, 5 years of the proposal. And have you justified this? And in parentheses here, I have put what part of the proposal will be, the reviewers will be, and the panelists will be looking at. There is this extended synopsis, I will go through this again, and then the full proposal. And the extended synopsis, of course, has to be like a sort of a summary in which you cannot go into the technical details. So, so this part of the proposal will be the evaluation will be focused on slightly different aspects. So novel methodology is important. As far as the PI is concerned, the questions will be, how has the PI demonstrated the ability to propose and conduct groundbreaking research? To what extent has the PI provided evidence of independent creative thinking? And to what extent have the achievements of the PI so far typically gone beyond state of the art? So independent thinking is a very important one, especially for the starting grants and consolidator grants, where the track record is maybe not as long. But I will mention this again, you know, what kind of criteria we're looking for in this. And then, so all of these criteria are important for everybody. And then if you're looking to apply for an advanced grant, we also are looking for demonstration of leadership in the training and advancement of young researchers, because that is really, at this level of advanced grants, first of all, the budgets are larger, the groups you're going to be leading are larger, and we have to have some guarantee that you will play your role as that you already have some experience and demonstrated that you can be a leader of a research group. Sound leaderships. So, and finally, this commitment. You know, to what extent does the PI demonstrate the level of commitment to the project necessary for its execution, and the willingness to devote a significant amount of time to the project? You have to commit to a different percentage of your work time to the project. It's 50 minimum. There is no maximum, it could be 100%, but the minimum is 50% for starting and 40% for consolidator grants, and for advanced grants it is 30%. And this is evaluated based on the full scientific proposal. This slide was already shown by Professor Jajszczyk. I will not talk about part A of this is the proposal structure. I will not talk about part A, the administrative part, but just wanted to sort of emphasize this distinction between part B1 and part B2, part B1 being the extended synopsis. This is the part that will be seen initially in the step 1 of the evaluation by the panel, and it has to present the project in a way that is understandable to a very broad range of panelists, because all the panels, I'm going to give some examples a little later, are very broad in their scope. Even within, say, you know, my panel, which is P10, which is geosciences, you have experts from, you know, geologists and also oceanographers and high-pressure physicists. They don't necessarily understand the jargon of your particular you know, area of work, and so you have to inspire a very broad you know, range of reviewers. And then it is also very important, of course, in part B2, which is the longer part, which is the 15-page part, you have to develop in detail, give all the detailed technical arguments in addition to the intellectual merit of your proposal, so that the reviewers and panelists can assess whether you are technically prepared to, and whether your proposal makes sense from the technical point of view. What I want to just say about this is that there is a tendency, I have seen that many times, of, because I've also been on a panel before I was on the Scientific Council, that applicants will repeat what they have written in part B1, that they will repeat it in part B2. It's a waste of time, it's a waste of space. You should not, because eventually the you really have to think about the goals of your project and how to defend the science in it in part B1, and the details go in part B2, but you don't have to repeat them. You have the 15 pages to really explain how you're going to go about developing your project, and where, in more detail, where it comes from, you know, what is the background for your project. Okay, so extended synopsis, okay. This we already saw, but I will have to repeat it. So as you know, there are these 2 steps, and in the first step, only the synopsis will be evaluated, and if you make it to the step 2, then it will be the full proposal and a more detailed analysis of your project. What is, the profile of applicant that we might be looking for? So for starting and coordinator grants, it's really independence, potential for research independence. And the number of publications doesn't count. You don't have to have had, some publications in very highly high-impact journals. That's not the criterion, but it is important to have done something that is independent of your PhD advisor. We need to have evidence that you can develop a research project on your own. And of course, scientific maturity and creativity, ability to develop a groundbreaking idea, think out of the box. This is how you present your proposal. For the advanced grants, we have somewhat additional we're looking for additional things, and we want to see the track record of significant research achievements in the last 10 years. And as I already mentioned, evidence for excellence in leadership and mentorship. So, have you published as a senior author? Have you been invited to international conferences? And I specifically put a number because it is not, again, as has been already mentioned previously, it's not the number of publications that counts, it's the quality. And so we just need to have some evidence of it. Maybe invitations to speak at international conferences. There are other criteria. You don't have to fulfill all of them, right? If you have had some awards, then of course you want to mention that. If you have organized workshops or international conference or even workshops here in Poland, all of this you want to emphasize. This has also been shown to show that we commit to support young scientists. 2/3 of the ERC grants go to early stage principal investigators, but here I wanted to point out that this is not this doesn't mean that the older or more mature investigators, so I messed it up, are excluded, and we do have a few grants or grantees that are over 70 years old, so there is still a chance. Also, we are very proud that we have, with some effort, but we have managed in the last few years to have actually an equal success rate by gender, right? We still have to work on encouraging more women to apply. In terms of the application rates, they are smaller. We are trying very hard to understand why and try to remedy it. But in terms of success rate, you can be assured that even in PE, we are leading the way, because in the recent competitions, females have a slight advantage. So finally, a few tips and advice. You have to be ambitious and daring. You have to, a problem often encountered is self-censorship. No, I cannot do this, I am not good enough, okay? Well, you can think about this initially, but if you think you may have some idea, and maybe if you work on it, it will become something good enough for ERC. I've already said that B1 is for generalists, so you have to target that for your presentations. You should not repeat, I already mentioned that. Familiarize yourself with funded proposals. Read some ERC funded proposals, see how they were written. That is very inspirational. And discuss your proposal with your peers, ask for feedback and advice, and take advantage of the available resources here in Poland that have been described. A few tips for the interviews, if you've made it all the way to the interviews, which is right now only for starting grants and coordinators, although we are in the process of implementing interviews also for advanced grant, starting I think 2 years from now. So you don't have a lot of time, you just have a few minutes, a few slides. You have to practice. You have to get your message across in a very short time. So the panels want to see in particular, that these are your ideas, that it is not somebody else that wrote the proposal, and that you are capable of defending your ideas yourself, and get them interested in what you're doing. And again, the panels are broad in their scope, so you have to think of it as if you were giving a public talk to the public. Preparing an application, there are many resources on the ERC website, so go and investigate it, put some effort into reading it. And so finally, I think I have just a little time. This is just to give an idea of a few of the panels, how broad they are. So this is, so we have 10 in physical sciences and engineering, ranging from mathematics to earth science. And you, of course, have to try and identify which one your proposal will fit in primarily. They are broad. Okay, maybe in mathematics it's, of course, understood how it is, but I want to quickly move to my own just to explain that some of them are really, really very broad, from geochemists working on isotope fractionation to Earth, planetary science, Earth system science, oceans, atmospheres, etc. These are communities that don't necessarily talk even the same language in many cases, so you have to pay attention to that when you prepare your proposals. Help is available, information for applicants and work program, step-by-step video, ERC website, ERC grantees experiences, the office here at PAN, and more information on the erc.europa.eu website. And finally, just to encourage you, I put this slide again that Professor Jajszczyk already shown. These are the time scale for the for the coming year or two. And again, preparing your proposal takes time. Don't get started 2 weeks before. Start thinking about it a year before, maybe 6 months. It will take time. You need several iterations. It needs to mature. It will not be wasteful experience, as Professor Jajszczyk already said. Even if you don't get funded, you will be much richer in terms of your scientific thinking or your experience if you fail, and you can reapply again. There are examples of grantees that have tried 3-4 times and that, from their own account, have benefited each time. Their proposal has become better, and once they got funded, they were, sailing much more easily through their project. So thank you very much. I hope I haven't got over time.
Fantastic.